A very good afternoon to everyone. So welcome to this session. We are going to discuss about DBMS, SQL and RDBMS, all the important concepts from these three subjects with respect to infyTQ. Okay, so to start in general, to have an idea about what is this DBMS or RDBMS, for every real-time application we use, it is important to store the data. If we take Facebook, Google, any of these websites, they would have stored all of our data in some format in a table, like our name, ID, password, and some of the other details like phone number, for example. Yeah, imagine we have three members with some ID. Okay, so this is how the data will be stored in the background. We will try to build up everything step by step, why it is taken like this and all those things. Imagine some password and phone numbers. This is the data that is stored. Why are we taking it in the table format? That is what we will be discussing now, and how to create these tables, the significance of these tables, and all those things. For every table, there should be a name, some name like details. The name of this table is details. Any data that is stored in the form of table will have relation with one column and another column. That means if suppose if I give a name, now if I am giving, for example, name, we obviously cannot get the details of that person. If I tell A, there are two people with the same name. When we take worldwide data, multiple people with same name, that's a possibility. But if I give ID, definitely there will be no duplicates in that. ID, this column is completely unique. To give a perfect idea, this is called column. Everybody knows, I'm hoping. So name is one column, ID is another column, password one column, phone number one column. Then these values, all this is the value of A, value of B. Then we have the value of C. They are called values. That means rows or records, they are called as. All the same thing. Then these are called as columns or also attributes. You need to remember these names as well for DBMS. If I want the record of a particular person, I have to get the entire row. If I want a property from the table, that means I want to know the names of all the people. For example, I am storing in the table. I have to use these columns. They are also called as attributes. The terminology is important for us. So this is a table. Now coming back to the relation, if I give ID, easily we can give name of that ID. If I tell a1@bytexcel.in, which person is using this ID, we can get that. Obviously, we can get password, but it is a secret. Then we can also get the phone number from this table. That means there is some relation between each column. Even if we give phone number, for example, with the help of phone number, there is a possibility to get the name, or of course to get the ID, but that is not acceptable because phone numbers are susceptible to change. Phone numbers can change at any time. Therefore, this ID is the important value here. It is called as primary key. What are keys? We can understand keys as like how in real life the term we use keys to unlock something, to unlock all the details of the table, to get all the details from the table, the important value, key element. The other meaning of word key is important. The important element from these column values we consider as primary key, and there will only be one primary key in any given table. We will see in terms of SQL how to create these tables. Now this is called a relationship. Suppose if we have another table where we have zip code, city name, and state. A table containing these three values, if I have zip code, I can tell city name, I can also tell state name. If I have city name, I can only tell state because in one city code, there can be more than one pin code. Okay, zip code in our general terminology is pin code. You can understand it something like that. Again, what is the relation that we have here? If I give pin code, we will be able to find the city and state. Obviously, it is dependent. City and state values are dependent on pin. That means there is some relation. If we can give certain relations between the attributes in any table, that is called as RDBMS. In general, everything is called as DBMS, database management system. So this is the general introduction to DBMS. Now let us see how to create code for the given table. Again, the general syntax for creating table is this one. As you can see here. So create table is a keyword. In this given example, what is the table that we want to take? Let me do one thing. Yes, you can see the table also. Create table. The name of the table, whatever we want. In this case, the name of the table is details. That is what we are expecting. Okay. Then whatever column values we want, those column values we can give. Details is the table name that we have here. Name is the first column name. All the columns we have is name is one column, ID, password, phone, right? In the same order, whatever you want, you have to take here as well. Name. Regarding this is called data type. We will see that as well in a short. Varchar is one data type. If you have idea, C language, Python, Java, whatever, in those we have types, int, char, string. Varchar is one of such data type available in almost all the SQL languages, whether it is SQL, MySQL, Oracle, all these. This 20 is the size. That means the name length of each name we store cannot exceed 20. We can give any number we want. So I'll give something like 15. Then not null. Again, this is a keyword. Not null. As the name null suggests, null means empty. Not null means it should not be empty. Definitely, whenever a person is creating an email ID, we would want that person's name. It cannot be null. So we are taking not null. The next column I want is ID. In ID, again, we will store some string. So varchar of different size, any size we can give. It should also be not, it should not be null again. The ID of a person cannot be null value. It is also a keyword. Now this is primary key. Again, a keyword. What is primary key? We have discussed already. The most important value in any given table is called primary key. Based on that primary key value, key means important, primary means one of the most important value here. Based on ID, we can get all other values. Then storing password is not feasible because in a table format, we will not generally store password. So let us simply take address or state or some country, India, UK, US. Let us take small names. So after this primary key, we would want to create a column for country. Country. Again, the data type, we can use anything. Varchar is for string data type. I will explain that as well. And size, maybe 10 is sufficient. This, even if any person is not giving their country, no problem. That means I personally don't want country. It is not an important thing for me. Then I am not writing not null here. Then finally we have phone, another column name. Of course, observe we have to keep comma. Phone number. And it is int data type. By default, phone number cannot exceed 12 digits anyway. This is the syntax for creating a table in MySQL, Oracle, SQL, almost all the similar database management systems language. Of course, since most of these languages are built upon C, C++, we will be using semicolons. These semicolons are important. After every query, we have to keep semicolons. Now on to a little introduction to MySQL, because keeping in view infyTQ, the most important thing here is you are not expected to create some code on your own. They will not give you a scenario, write the code for this in MySQL. They are not asking that. They will give the code already. You have to find the errors in that if there are any, or execute yourself in your brain. It is called control flow. You should be able to solve this control flow on your own and find the output with the given input. They will give some input, you have to find some output. So you need to know at least little of these basics. Then, so SQL is a structured query language, in case anybody is interested in that. There are many, like a programming language. There are many programming languages. Even in SQL, there are many languages, but they are query languages, not programming languages. MySQL is one thing, Oracle is one thing, my MS Access or SQL Server for that matter. There are available many things. Then there are few rules when it comes to MySQL. It is not case sensitive. Imagine there is a function called round function, which will round off to the nearest integer. This round function or any other keyword or function for that matter, whether you are writing in caps letter or whether you are writing in lowercase, for SQL languages it is same, except for MongoDB or special MySQL versions of this SQL languages. We need not follow case of the letters. Case is insensitive. That's the reason I have given here, whether round, capital or small, okay. But the convention is we will use capital letters. Again, rule is different, convention is different. Convention is we generally follow that so that it will be easy for us. By looking at it, human beings will be able to tell. So the convention of SQL languages, SQL languages is we use capital letters. All right. So I am also throughout this session, I will be using capital letters as well. Then as I told, to separate each statement with one another, we have to end with a semicolon. We need to take care of that as well. These are the two important things that one must keep in mind, because in exams, they will give you options. If we take this example, they will give a table like this. They might ask, pick from options, which of the following option will create the following table. Then if they are giving same options, for example, one with a semicolon, one without a semicolon. So D9, this block does not have a semicolon. C9, this block have a semicolon. The answer will go to C9. That is the reason few rules are important for us to remember and understand. Then data types. We need not, one need not know all the data types available in MySQL or SQL, because MySQL, SQL Server, Oracle, again, Microsoft has a different version of SQL. There are many differences in these data types. But these are the common things. One most used data type is a char. If you want to store any string value, what is string value? Group of characters. Any characters which is written either in single quotation or double quotation is called as a string value. And this string value, if you want, like name, ID, these are strings. Phone number, they are integers. If you want to store string value, you have to create a char. Then what is varchar we have been using is the major difference between character and varchar. If I am creating char 20, automatically 20 bytes of memory would be created. And so on. This is an example number. Since most of them are built on C languages, one character will occupy generally 1 byte. So 20 bytes is fixed. Even if I am storing very small names, for example, if I am taking very small name like Sai, this should contain only 3 letters. the name Sai is having only 3 letters, which should occupy only 3 bytes of memory. But what will happen when I'm taking char 20 is, even if I'm taking Sai, the name, some name, to store 3 letters also, it will creating 20 bytes of memory. That means the type of memory is static. Once created, cannot be modified. But varchar is dynamic. Why dynamic? If we are giving a small name like Sri, only 3 bytes of memory is required. Therefore, automatically the engines of DBMS, it will create only 3 bytes of memory. That is the reason 99% of the scenarios we will be using varchar. Even if you are seeing char anywhere, there is not much difference. Only memory allocation differences are there in the background. Okay, and of course we have many such things available, as I told: binary, text, set. The most important thing between the differences between all of these is the size, the capacity. Text line number A14, it will create a very large text which can store up to 255 characters. The maximum of a text variable is 255 characters. Then we have set also. You can give multiple values in that, multiple string values. Then when it comes to numeric data types, again we have many, but the important data types are only discussed here. Whether it is int of size or integer of size, both are same. That means if you see both, no need to panic, both are same. Then float to create decimal values, double or decimal, again both are same. The capacity is different. In our example, I have already shown you, I have created int of 10. It is actually not it, it is int, the data type. That means integer value of size 12 maximum. I am creating a data type. Memory allocation will be done. So Boolean value again for true or false, but since it is based on C++, in C language there is no Boolean value. 0 is considered as false. Any value other than 0 is considered as true, or by default 1 is represented for true value. So that is the same thing is happening here as well. Okay, then when it comes to date and name types, these are also important because they might ask you few topics from this. For storing the data, if you see this date in capital letters or small letters, that particular column data type is to store the date format in this format. If you see date time, both date with year, month, and date, and time as well will be taken. Then timestamp, then timestamp, it will work a little bit different. Time will give us exactly the time in hour and minute and second format. Timestamp from a given point of time, how many seconds or hours has elapsed, how much time has gone, that much, that value can be taken with the help of this timestamp. And year will give us the year. Generic names, if we understand the general process, that would be sufficient. All of these follow a simple process. These are the types available. Whenever you come across them, now you can understand in an exam. I'm repeating again. When you go for these exams, they would have already given questions. First step in learning anything is, whatever question you are shown, you should be able to point the error in that or tell the output. If one is in that particular stage, through practice, we can evolve into creating something on our own. Then we have operators. You will be seeing these operators as well. And arithmetic operators, it's normal mathematics or any other language. There is no specialty actually. Addition, subtraction, multiplication, and all those things. Even comparison operators, when you want to compare two values equal to, in SQL, we don't have a comparative operator like double equal to. If you want to find out the values, whether x and y are equal, you need not do x equals y. You will get an error. It's simply enough if you just check x equals to y. Okay. Then in comparison operator, one extra thing we have is this one, not equal to. If you want to check whether two values are not equal, obviously not equal to is one thing. Also, less than, greater than symbol put together will also give not equal to. You need to understand that this not equal to will also work. Okay, then we have one logical operator. Again, like any other language, to give you a general idea of these logical operators, we have and. How this and would work is, if we have x and y, this statement will be executed only when both the values are same. If x is true and y is true, then only x and y would be true. Like that, to check the logical values between any two or more given statements, we can have this logical operators as well. Exists and like we will be discussing more again soon. All and any, they are also simple. All, when we use this, if I ask all of some variable, some place, all of, for example, if I'm taking like this, all x, in x memory location, if all values are true, then only it is considered as true. Even if there is one false, if x contains 0, 1, 2, 3, 4, x, there is a zero value, that is there is a false value. So all of x would also give us false value. These are the general operators. We will be seeing these operators again very soon. Now, generally creating database, creating usernames are important. So that if we see this syntax, we can also understand what type of keywords we have, how we can use these keywords. Create, drop, rename, select. These are four of many keywords available in SQL languages. If you want to create something, use create, drop something, use drop, rename something, rename, select something, select. The names are very similar to the real life language we use. So what is a database? Now comes the actual question. We have discussed tables, column values, rows and everything. A table contains data. If we take any sport, for example, cricket, if we take, while batting, we will generally they will display a table which contains the data of number of matches played by the person, number of innings played by the person. That means the batting he or she might have done, number of runs scored. It's a table with two columns, side headings, and it's their particular values. If you see the bowling, we will have more options: economy, bowls, boundaries given, percentage, many things. It's table. We store in the form of tables. It will be easy for us to access. Now, if you look at this Excel, Google Sheet, there are many values, thousands of values we have in this. If this is a normal document, communication would have been very difficult. Since it is a Google Sheet, if it will directly be 30, for example, control is going here. We have more control over data when in table format. But then what is DBMS? What is database? collection of all these records or tables is called as database. So simply database is collection of all the tables or documents, fields, sometimes even collections, we call it as collections. If it is a no SQL language like MongoDB, it is also a database management system only. There, instead of tables, we will have collections, separate records. So this is an apt definition for that. So these are the keywords. If you want to create something, create database, give any name you want. To give you a best example, this ByteXL DBMS is the name of the Google Sheet, and these are the tables present in our Google Sheet. Okay. These are when we want to compare it to the general DBMS structure. All these tables will have individual names, like MySQL is one sheet name. Sheet 1 is one thing. Join, it's an important concept of SQL. This, all the details I have written there. So this is one separate sheet, but together all of this is ByteXL DBMS. In this file, all the data we have. Same way, all the tables, you can have any number of tables. All the tables put together, you have to keep it in one database, and that database is similar to this file. If you want, first we have to start by creating this database only. Okay. All right. If you want to drop, whenever we are dropping, it is deleted. And again, we will be seeing about all these keywords in a little while. Yes. So these are the important tables that we will be seeing. Using these keywords, most of the questions will be asked for almost all exams. We have already seen how to create a table, create table, give the table name, and follow the structure. Name of the columns, name of the data types, something like not, null, integer, and all those things. They are called constraints. We will see a list of these constraints as well. Once data is created, here we are creating the table itself. That means in this language, we are defining how data should be stored. Therefore, this is a data definition language. Creating table is part of a data definition language. Then select. From the table given here, we have created the table. We have inserted the data as well. How to insert the data? It's a step-by-step process. We will see. If I want to select something, suppose I want the list of phone numbers of all the people available in this details table. Then I have to select. Use select. It is a keyword again. If I want only one column, give the column name phone. From, again, from is a keyword. It is better to note down all these keywords, separate keywords on one place, functions in one place, so that it would be helpful for you. So select phone from. What is the table name? Details. Now from a table called details, phone record, phone attribute is selected. Phone is the name of the column. I am selecting all phone numbers. So I am selecting the entire attribute. Then suppose if I want the all the values, not just one. Other syntax available is select star from table name is mandatory, because from where we have the engine of DBMS should access the table. We don't know. So giving table name is important. Now select star would select all the values. This is also one available syntax. So select star, all values or a single column. Now this select is one keyword. Then come to alter. Once create table is created, I would want to change its columns for some reason. Maybe a country is not enough for me. I would want to add some extra detail called, actually not just one, I would want to add two extra details. For example, called pin code and city as well. So I would name them pin code and city or state as well. Now what I'm doing, I am changing the entire table. So all these values by default would become null unless and until we add them, right? For that, to change the table, we have a separate command alter, alter table, table name. For first two examples, we will be seeing the entire code as well. From there, it will be self-explanatory. You will understand. So alter, as you can see here, alter table put together is one keyword. Then give the table name. If you want to add something, add followed by columns. By default, whatever columns you are adding, they will be added at last. That means if I am asking alter table, give the table name, details, add some column name, pin code, state. But this is the first time I am adding. Whenever I am adding first time, I should also give its definition. See the definition. What do we mean by definition? Constraints. What are the constraints? Pin code, which should be in the form of integer, and give some size. That means I can store in pin code only integer, not exceeding size 10. If you want it to null, you can keep null. If you don't want null, don't keep not null. Again, these are all constraints. If you want, you can keep up primary key or foreign key. Foreign key is one other key like primary key. We will see that right now. Okay, once this coding is completed, we will discuss about foreign key as well. I want this pin code to be a foreign key. Then I will give that. It is also an inbuilt word, reserved word. But if I am adding this pin code like this, by default, this column will be added at the end. What is the last column as of now? Phone. It would be added here. I don't want that. Then we have an option available. I can manually give where I can store this foreign key. I can give by default it is taken as last. This is not reserved word. We need not give it. If you want it to be first column, we can give first. This is a keyword. Or if we want to store after some value, this is the proper syntax. We can either give first or after a particular column. So I want this pin code not even in first. I want it after what column name? ID. So I will give like this. ID is not a inbuilt word. So this is how we can alter the table. Now altering the table, again, this is part of a language, but what language? I am manipulating, I am defining the table again. So this is also data definition language. I am changing the table itself. I am not changing the data. So this is also part of data definition language. Then for everything, the concept is same. If you want to modify some column name, like here the name is ID, I want to change it to email, suppose. Then what I am doing, of course I am altering, but directly I am modifying. So to make the work easy, we have separate a keyword called modify. If you want to delete a particular column, entire column, I don't want to store phone numbers, then I can drop the table, rename the column, delete, truncate, copy, temp. As I told, there are many other keywords. All of this, they form data definition language. Now, before continuing, one important thing everybody has to remember is, in the example we have taken, there are only 3 values. But the reason this subject has evolved so much, actually the official concept of DBMS started in 1960s. But the algorithms for this have been around since 1940s. Of course, not in our countries, but where in US most of the times. From that time, why is it important to maintain and create these different subjects and different algorithms, everything? If the data we are storing is becoming very, very, very large, which where we are accommodating lakhs of or crores of records, then we need to come up with proper rules, proper algorithms for storing this data, for creating first, then for storing, then for accessing. So all this creating, storing, and accessing will form a system to manage the data, since the name DBMS, database management systems. By default, since it is built on different languages, we have an option called view. What are these views? Views are very important actually. If I have multiple tables, let us take this table. In one table I have the details of student, in other table I have details of their payment. Now I only want to see this column from student table and fee column from payment table. Again, here there are only 2 columns. What if I have hundreds of columns? Name, address, state, pin code, phone number, alternative phone number, gender. We have many columns, right? Among hundreds of columns of each table, I want to see only 1 or 2 columns from each table. Then views are important. That means whenever I am creating, we have seen this keyword already. From here on, almost all the keywords that we have seen will only be coming. We will be using only them. Create or replace. Let us come to this replace later. Create view. View is also a keyword. Some view name. If I am writing an example for this, here we readily have multiple tables. So let me take here. Yeah. Create. Forget about this replace. View. We can give some view name. Let me give it as view1 as select. I want name column from student. Therefore, I can directly give student dot name. Like in OOPS concept, how we can access an object attribute. If I want to access a method of a class, I can use class name dot method name or object name dot method name. Same way, student dot name means go to student table, access name column. And at the same time, I want another value as well. Go to payment table, access fee column. From where? Yeah, we can use this also from table 1, table 2 can be given. Therefore, this is also not required. That means both are feasible. We can follow anything. It depends on depending on the situation. We can follow anything. Table 1, table 2. In this case, the details of table is one is a student, the name of the table. The second one is payment, the name of the table. Where is a special condition. I want only those details whose fees is greater than 30,000 or 29,000, for example. That means when you want to give certain conditions, we have to give where. So I will give where fee, the column name, it is not a keyword, it's a column name, is greater than 29,000. Views are not real, they are virtual. So no new table will be created. But what will happen in the background? Simply, I am creating a shortcut to make it more clear. Let me show you one inbuilt feature of this Google Sheets as well. Imagine this student table is very important to me. In all the sheets, I want to use this again and again. Copying and pasting and using is never an option, because if there is an error here, when I copy paste this in different places, even the errors will be copied to different places. So that is not an option anywhere, anytime. What I can do is, we have an option in Google Slides or even Microsoft Excel, any of this. We can create something called named ranges. No need to understand this, what I am doing or how I am doing. You need not remember that. I can give some name, student details, and done. Whenever I want to use this student details anywhere in my database, as we have seen, this is the database. Suppose in MongoDB, this is a separate sheet. Here, if I want to use that value, suppose student details, I want to create a program. When I press this on student details, the control should go there directly. Now what is happening? If I press this, automatically from different tab, where I am in this MongoDB. The data I want is in this join sheet. Even though what is happening, I am pressing on the link, automatically the control is taking me there. This is the original table, but what is happening to this here? The student details, is it copying the table? No, it is just providing us a link to the table. And of course, here we can provide link to multiple tables as well. I can add the link to another details as well. For two tables, I can do that simultaneously. The same thing, our Microsoft Excel or Google Sheets, they are also some tables to store the data. We can use them as an informal databases. So most of the rules we follow will be similar. Same thing is happening with the view here, which is not copying a table, but it will create a temporary link to the column names that we ask. In future, whenever I ask view 1, I can get one column from one table and another column from another table. These are views. They are also important again. Once we cover all the basics, then we can see how to actually insert data into the created tables also. Whenever we have documents, generally modern day is collaborating. We will collaborate these documents with our other team members. So in real time, when I am typing this document, all of my team can see the document I am seeing. If I am making any mistakes, they can add comments to me. So as you can see, we can add comments there. The same option is available in our DBMS also, like sharing with others. When we are sharing the documents with anybody, we can lock the data from being copied, and we can keep some access, we can keep some control. Again, this is forming a language to control the data. Therefore, the name is given is DCL, data control language. Generally, we can lock the tables based on that. We can grant permission, we can revoke permission. This is once if we are locking the table cannot be accessed. If I am giving it read permission, any person can only read the data from the table, and so on. Finally, moving on to the constraints we have. Not null we have seen. If we don't want a particular column to be null, we will be taking this not null. Then primary key, where we have to use this, after the name of column, we will give data type for that column. Then we will be using something called constraints. We can use multiple constraints also together. Primary key means that column is very important. By default, primary key cannot be duplicates. If you don't want in a particular column to allow duplicates, we have to take unique. That means in this name, suppose if I don't want after not null, if I take unique, what will happen is this name will give me an error, because person 1 A1 is having the same name, A2 is having the same name. Whenever we don't want duplicate values, we have to take this unique. Of course, on name attribute, we should never take unique, because multiple people can have the same name, right? Then foreign key, as I told, we will discuss that. It is one form of the key, which is again quite important. Unique we have seen. Check is for checking some condition. Some situations we will use where, some situations we will use a check. Default, we can give some default values. For example, as we can see in the example here, I am taking a column called country, and I don't want the users to give mandatorily this value. If anybody is not giving, by default I am taking it as India. That is the value of default. If user is not giving anything, we will take something. Then we have auto increment. Whenever we take auto increment, what will happen? If the first value is 1, like in this sheet, if I have some other value called some serial number or some other number, if the first value I am giving is 10, next value 11 automatically will be taken, and this will be seen by DBMS engines. Storage engines will take care of that. We need not worry about that. Like that, we have a big list. Then on to the next important concept in DBMS, SQL. Once table is created, if we want to store the details into tables, we will use all these concepts. I have created a table like this, but where did we insert these values? We did not insert through programming. If we want to insert that, this is the keyword we have to use. Insert into, both are keywords. Give the table name and give the values, column values you want. First value will be stored in first column. Second value will be stored in second column. That is, 1 will be stored in ID of a student table. Imagine there is a table called student. Then A will be stored in name column. O plus O positive will be stored in group column. Some 1, 2, 3 number will be stored in phone column. That means in this table, if you want to insert the details, we will use insert into name, ID, pin code, state, country. Insert into details of name, ID, pin code. I don't want to enter pin code, so I need not take state, phone. Whatever values I want to take, only those I will copy. That's all. Into the column. Then give something called values and enter the values. Values. From the table we have, I am giving name A. ID is again a string, so A1 at the rate of bytexcel.in. Then I am expecting state, which is a string again. Some state. Then we are expecting a phone number. Some phone number. If you want to enter multiple values, this is the syntax you have to use. We can actually give all the values at a time. Just give values and comma separated values you can give. So in the same example, then in the second place, just give name of the B, name of his or her B at the rate of bytexcel.in. Like this, we will be entering multiple values. They will display these sentences, whatever I am showing will be displayed there in your exam. They'll ask whether choose the correct answer or what will be the output of the following. Such kind of things will be asked. Now, all of these are one thing. These are the basic concepts that are required. Then two important concepts, join and normalization. These two are one of the most important concepts. One is a theory concept of DBMS, one is a coding concept of SQL. Let us take a 5-minute break now. The time is 3:15. Again by 3:20, let us resume the session. Yes, welcome back to the session again, everyone. So far in the session, we have seen the basics of RDBMS, SQL queries, how to create queries on our own and everything. We have discussed much. Now coming to the joins operation, it is very important. Let us see that. Before starting this concept, everyone must keep this in mind. We are not going we are not discussing these topics in a sequential order, not like a semester value. That means, what is joins, why join is important, why we have to use these joins, all of this will fall under theory concept which we are avoiding to discuss as of now. Simply, for some reason, if there are two tables or three, four, five, any number of tables, multiple tables, if we want to join the data of these tables, we use the concept called joins. So to give you a very quick idea of what this joins is, as I told, one, you can observe there are two tables here. One table contains student details, one table contains payment details, that is fee details. And the common attributes we have, actually according to the name of the attributes, we don't have anything in common, because if you observe carefully, one is IDs, there is S, that means it is different. It is ID, both are not same. And according to the concept, the name of the columns is not important to us, as long as there is at least one common record in both of the types. Here we have 101, 102, 103, and in the other table also we have 101, 102, 103, some common values. If we have at least one of such common value, we can combine the tables. So these are joins. As I told, when you want to join two tables, we use this concept. There are basically three types of joins operation: natural, then we have outer, and inner. Inner is also known as equi. Both are same. Natural means normal. Then we have outer. Again in outer, there are three types: left outer, right outer, full outer. The names might be stylish and confusing, but in reality, they are quite easy concepts and understanding concepts. Let us start our explanation from here. This is not exactly for outer join, so let us remove that. We have details of table 1, then another table with the details 2. Some table we have different tables, that's important actually. Here we have 101 to 104. In the other table we have 101, 2, 3 and 5. This is a different value. But at least there are three common values. Even if there is one, that is sufficient. Then the first type of join is natural join. When you use this natural join, what will happen is, this is how the data will be represented. The common attribute cannot be seen in the final answer. First, let me tell you the first table step by step clearly. From the further tables, easily you can understand. Okay, the first value we have 101. Let us try to understand the concept first, then we can see the coding part of that as well, because it is expected that 3 or 4 questions can be seen based on these joins concept. They will give you different tables and they will ask you which query you have to select. If you are able to know the correct answer, if you are able to build this up, then in exams it will be easy for you. So first we have 101, a same ID in both the tables. I am selecting name column and phone column. Even if I have an extra value in this given table, it does not matter actually. So to give you a still more clear, let us assume this. Some extra values can also be present. Instead of phone, let me take some other value called city, or let me take state, some Andhra Pradesh, Telangana, Tamil Nadu, Himachal Pradesh. All right. But I am selecting, we can select actually only few columns we want. I am selecting only these 2 columns for now. Therefore, you can see the 2 columns here, only 2 columns. Then how join operation will exactly work is, first 101, always the default value, if you are not selecting, there is a concept called associativity. That means left to right, the way of reading or writing, there is one concept. Also right to left. In programming languages, any language it is, generally it will be left to right only. Under special circumstances, it will be right to left also. So the left table ID is 101. What is the name of that ID? Sanjya. Some example name I have taken. The name Sanjya will be visible here. In the answer table, it will be added. Then in the details to table, again I am taking only phone number, not the state. ID 101. What is the phone number? 123. Both 101 name is taken, 101 number is taken. The same process will be done for 102, 103. Both of their names are taken, both of their phone numbers are taken. That's all. Why? Because it is a natural join, only common values will be taken. Only common values. That is natural join. Then outer join, when it comes to that, we have 3 types: left outer, right outer, full outer. So first left outer join, again for the same table, for your clarity so that you can understand easily, let me copy paste these two after each session. Yep. Again, the same table I am taking. On this same table, if we are joining the tables based on the condition left outer join. Again, the process is same. What are the values that we have considered? Name and phone only. Therefore, ID is 101. The name will be taken, phone will be taken. But the thing is, as I told you, left outer join means all the values of left side table should be taken. Why? What difference does it make? You will see now. So we have 104. something like Mahesh, the name from the table above. Yep, perfect. This is how the table will be taken. We have first three common values, like what happened in natural join. Same thing should happen here as well. So the first three values are copied normally. But since it is left outer join, the stress is on left side. That means left side table, all values has to be taken. What is the name of 104? Mahesh. So in the name column of 104 ID, Mahesh is taken. But we don't have 104 here if you observe. That means there is no phone number associated with 104. Therefore, it is taken as null. And general syntax of this is left outer join. Details 1 on details 2. Which table you are taking first is important. Since this table is on the left side, we are taking this value. Again, left side in the sense, while writing the code, we will see that. Again, for the same table, if we take for the same table, right outer join as well. So the name would be 105 and some name we have given. There is no name actually for 105. If no name, we will have to take null value. This is the perfect table. What is right outer join? All the values, all the records of this table has to be taken. First three members, we don't have a problem. 103, their names and phone numbers are available, taken. When it comes to 105, now we are not bothered about this table. Only this table, all names have to be taken. 105. What is first column? Name. What is the name of the person whose ID is 105? In the name table, we don't have a 105. Therefore, since it is not available, it is taken as null. Then coming to phone number, yes, there is an associated phone number, it is taken. This is how left outer join, right outer join would work. And the final join that we have is full outer join. Now this full outer join, again, it will work a miracle. All the details from both the tables will have to be taken. That is how this will work. So first all the names will be taken. Then their respective phone numbers will also be taken. To show you the tables all at a time, here is the data. What are the columns I am selecting? Only name and phone number. So a table will be created with both phone numbers, name and phone numbers. Basically, full outer join is union of left and right outer join. If we are doing a union operation of left and right, then the full outer join will be created. I am repeating again. Since I am selecting, once I write the code, it will become more clear to you. I am selecting only name and phone number. Therefore, only two of these columns are visible in the output. If we select a state also, that will also be seen. But I don't want it, so I am not selecting. Why? Just to tell you with clarity that we have a choice to select what columns you want, how many columns you want, from which table. The control is completely in our hand. That is the reason the states are not visible in the output. So if anybody has that kind of doubt, it should be clear. All right. Full outer join is basically union. That means all the names from left side, all the names. Okay, let us not concentrate on name values. Let us concentrate on ID. Common 101, 102, 103. What is union? If I have set A equals to 1, 2, 3, 4. And imagine I have a set to 2 equals to 1, 2, 3, 5. If I am making a union of them, then what would happen? It would be 1, 2, 3, 4, 5. Without duplicates, all values will be taken together. Therefore, name of 1 not 1, 2, 3, 4 and 5 will be taken. 1 we have, 2, 3, 4 we have. What is the name of roll number 105? There is no name. So null is taken. What is the phone number of, again, 1, 2, 3, 4? For 1, 2, 3 we have phone numbers. For 104 there is no phone number. So null is taken. 105 no name, null is taken. 105 number is there, it is taken. This is full outer join. There are other names associated as well. But these are the general concepts of joining. Then we have Cartesian join. As I told, many things are available out there. These are the important of them. Then the final one or the last one. Inner join, or sometimes it is also called as equi-join. So imagine we have this table with ID and name same. First one, if we have about this inner equi-join, we need not have common values as well. Just if you want to join the tables entirely, completely, without any common value also, we will be using this. If common values are there, based on those common values, table will be joined, or else generally table is joined directly. As you can see in the output, we have entire first table values, we have entire second table values. This can be here as well. This is the inner join. So these are about joins operation as told already, which are very, very important. Now let us see how to write coding for this join operations that we have just discussed. First, inner join or normal simple join, whatever we want to call, it would work for everything. Imagine we have two tables like this. The names of the table I am taking is simple, table 1, table 2 for now. And we have some employee, for example, employee ID, employee name, and some state. State ID, state name, some city. There is absolutely no relation between these two tables at all because one is employee, one is a student. But even then we can join the tables. That means any programming language or whether it is a query language, SQL, MySQL, anything, they actually cannot decide or they cannot understand which tables, joining which tables is important, joining which tables is useless. As a human being, we have to decide that. We have to take care of that. What is the use of joining a table which contains the details of a student, tables which contain details of employees? Both are different sectors. Okay, to tell that example only, I am taking these kind of tables. which are unrelated. There is no relation at all, but still join will work. Now let us see how this joining will work. There are few things you have to know. First, as I told you, left side table, right side table. The order is important. You have to decide from which table to which table you are using this join operation, and also based on what column we are joining. If I want, based on these columns, I want to join the table, I have to know that first, because we will be using that in the code now. Now take a look at the code. All right. Okay, so this is the code that we are interested. Again, if we take a look at one code, the entire concept will be understood. How to select a table first? We using select a command. Since there are two tables involved, directly we can take from which table, which column you want. From table 1, I want only name column. So I am selecting e1.e name. I want only that. Then from table 1, I also want state column. I am taking that as well, state column. From table 2, I don't want name of the students. I don't want IDs of the students. I want only their city. Therefore, table 2 dot city. We have selected all the particular attributes we want from these tables. Again, left side table, right side table, we have to decide that. Because as we have seen, left outer join, right outer join, the order is important. Therefore, what is the syntax for that? From table 1, join table 2. So table 1 is on left side, table 2 is on right side. If you want, you can take reverse also. A very simple syntax. What type of join I want right now? Inner join. We have seen inner join or equi join, both are same. Outer join, left outer join, right outer join, full outer join. These are all the keywords in the DBMS. So this inner is a keyword. Join is also a keyword. Order is important. We have specified the order as well. On. What is this on? It's a keyword, as you can see. But based on what attribute you are adding the tables. For now, I am adding from table 1 employee ID, from table 2 yes ID, that is some student ID that I have to give on what, that I am specifying here. This is the syntax. Since we have seen all types of joins, the only thing you have to change here is in place of inner join, you can give outer join, which is for general full outer join, or left outer join, or right outer join. Those are the keywords that you have to use. Then what will be the answer once we are joining them? It is inner join. So the tables, all the values will be added. If you take just left join or just left outer join, it is same when it comes to languages. Excuse me. These are keywords. In place of inner join, the only thing we have changed is changed it to left join, as you can observe here. Either left join or left outer join, both are same. The same thing will go for right outer join as well. Then one more join we have, important join. Cross join is yes, imagine this is the table. Small tables. This is one table with some details. The whatever details we have, it's not important. Excuse me. This is another table that we have. Two tables. We have seen all types of joins, but from coding point of view, there is one more thing available as well called cross join. What is this cross join? The syntax is same actually. Select column from we are selecting all values. Again, we can select one column, two columns, the same story again. But if I select all columns from table 1, cross join table 2. That means to explain the concept, I am taking small possible statement here. The new table that is formed is a very big one now. These are all the values that are available in this given table. And the reason is very simple. What did we just do? Do cross join. If from normal mathematics, if you see, 1 will be mapped to both 1 and 2. Each value is mapped to all the two values of other table. Then 2 of this map is mapped to first value. Again 2 of this table is mapped to second value. Same thing should happen with 3 also. 3 is mapped to first value. 3 is also mapped to second value. This mapping, this is called relations actually. This mapping, employee ID is repeated 3 times. For each employee ID, student ID is repeated again and again. And column names all will be taken, and phone numbers based on the availability of the phone numbers, it will be taken. Based on these IDs, the phone numbers would be taken. This is cross join. That means it is like a Cartesian product, cross multiplication in matrices, how that would work. Same thing. Each value is taken grouped with the other values. So if you have two sets, one set containing A, B, C, for example, and the other set is containing 1 and 2. The cross product of both of this, again mathematical concept. First pair we have A comma 1. Second pair we have B comma 1. Third pair we will have C comma 1. From left side all the values are taken, and this is not over. The same thing will repeat one more time, but this time with value number 2. That is a second value available. This is Cartesian product or cross. The same thing will happen in a cross join. These are the joins tables. Excuse me. Which are important concepts. Then the next important concept that we have to discuss is normalization. But before going there, we need to see few keywords. We have seen select, we have seen from already. Select from table columns, we have select column from table. That is how we will use both of them. Where is used for a condition where certain column value is greater than some value, less than some value. Only those particular values we will be considering. Then group by. What and how this group by will work is, suppose if I want to count all right, imagine we have a table. If a table contains ID 1, 2, 1, 2, 3, 4, 5, some person A, B, again A, B, some C, D, E. Initially, A has done some 10 questions of work, maybe 10 marks A got. We got 20. Again, A got 15. We also got 20. Yes. Now we have duplicate values present in our table. What do we mean by these duplicates and how these duplicates will work? Simply, if I am select, let me give you a column names. This is ID, this is name, this is marks. Then I am asking the machine select name, this is not a keyword, from some table 1. Imagine this is table 1. I cannot use a where condition now. So what I can use is I can group them, group by, which is a keyword, group by name, having a keyword marks greater than some 20, 25, some value, whatever you want. Now what will happen? The machine, the database, what it will do is it will group by. What do we mean by group by? If I say all boys form one group, all girls form one group, or if I say all the people whose names are starting with letters A to N form one group, O to Z form one group. Okay, we can find some commonality, something like that, or maybe all CSC people form one group. Based on condition, we can form into a group, and then I want to calculate. In a class, if there are 60 students, both boys and girls, if I want to take a statistic, how many boys are there, how many girls are there, how would we count? We are human beings. Directly, we will look at a person. If it is a boy, I will add a counter to boys count. If it is a girl, I'll add counter to girls count. But since this is a machine, it cannot do that directly. We have to tell it how to do it. We are grouping by. What do we mean by grouping by? All what I am giving group by name. Therefore, it will check for all the A's. It will group both of them. That means their marks will be added. 10 plus 15, 25. Of course, we have some functions associated with it. This is the exact syntax where we can use group by. So imagine we have a table like this. Names are repeated. So select a name. Now this sum excuse me. So select name is a column. Sum is an inbuilt function and some marks. I want to find the sum of marks. Sum of marks of the students. But each student is having multiple data, right, in our table. We can't do that directly. Now this is called aliasing. Whenever you see as in Python or DBMS, it is called name alias, like aka, also known as. So a separate table with total marks as the column will be created. From students, we are taking group by name. That means if all the A's together will be grouped, all the B's together will be grouped, C, D, everything, they will be grouped together. Then sum of each mark will be calculated. So this is the answer. The name will be taken because I am selecting name. Total marks is the column name that I am giving. Marks of A is 30. From this table, if you see, A initially got 10 marks, then A got 20. Sum I am using, it is one of the inbuilt functions. So answer is 30. Then we can also group by multiple values. How that would work? Only the common values will be taken. If you are grouping by multiple values, always remember only the common values will be considered. Then the same thing goes for order by, this ascending order or descending order. If we have multiple values in the order by, imagine this is the table. So order by, if I am doing for ID, here it is in random order, that will be taken in proper value. So 2, 3, 4, 5. By default, it is ascending order. If you want, you can specifically mention this DESC for descending order. And the final concept to this coding part before seeing normalization is the order in which the values will be taken. If at all we are using all of them in a single statement, this should be the order. First should be select, then from, because select to what? What you want, you have to tell first using select. Whatever you want, where is it present? So you have to give the address from. Then instead of getting everything, we have to give some condition where. If you want to group by together, then you have to use group by. We have seen the condition for grouping, again we have to give here. We can give here having. If I want to group only if their marks is greater than 25, then I have to tell that. Then finally order by. By default, the tables in the DBMS are unordered. That means they are not in a particular order. it will be very difficult to access the first value, last value, everything. We have to use this, or excuse me, we have to use this order by. These are all the necessary and important concepts from SQL, MySQL, that you can see in the exam. One thing all students have to keep in mind is, like any other language, MySQL is one programming language. You have MySQL, SQL, SQL Server with small variations. There are also different functions available in different of these languages. So without preparing all of them, have to attend the exam. The simple answer is, if you know the structure, what keyword should be used first, what keyword should be used next, if you know this order, then that is sufficient. Now if I say group by, you know what it is. Then suppose if I am saying limit to 2, what is it? You need not even know that limit is a keyword, but you can simply understand, because they are asking it is a keyword. Limit, what is the name of this limit? The same thing. If I am asking select a name from some table group and everything, if I am giving limit to 2, that means if this query, let me take marks greater than 15 for example, so 20 will be, only these three values will be taken. That means I can see all the three values in the output. For example, if you see, think that limit to 2, what is the meaning of that? Only first two values will be taken, because I am limiting the output. That means based on the general meanings in English, how we use it day to day, the same meanings can be applied here as well. That is how, even without a proper clarity, you can still attempt the exam. Then coming to one of the last and most important concept again is normalization. Before discussing normalization, there are two concepts every student has to understand. The first concept we discussed is, there will be some sort of relationship between each columns in a given table, and that relationship is called dependency. What is the example? If I give you ID, you can give me name of that student. Same way, if you want a name, you need to have access to ID. Because if I know the name of a student, for example, I know a student named Karthik, imagine, from IIT Delhi. I don't know the person, I just know the name. If I want to find out the details, if I say this name, I cannot get the details, because number of Karthiks will be there in any given location throughout India. It is not possible. Therefore, the name value in a table is dependent on ID. Unless and until I give you ID, you cannot give me the name of a person. This dependency is called functional dependency. Name is functionally dependent on ID. That is how we call it. Generally, how it is done? Some primary attribute or prime attribute, that is important attribute, can give us the details of non-important attribute. Again, what is this prime attribute, non-prime attribute, and all those things? Simply let us take a table which contains ID, then some name, pin code, city. Yeah, I think this is sufficient for now. If we have these four values, of course, one dependency, one relation I can find in this table is ID is dependent. ID will give us name, of course, a PIN, and city of the person. This is one dependency that we have. All three of them are dependent on ID. This is called functional dependency. Then also there is one more relation here. If I give you PIN, at least you can give me the city, definitely. Therefore, again, this is some sort of dependency. The dependency is called transitive dependency. Why is this name differences in the name? Simply, ID is a prime attribute. One ID will only be there for one person, but PIN is not a primary attribute. From the same PIN code, multiple students or multiple employees can be there. If we are seeing the database of Aadhaar card, for each PIN code, thousands of people will be there. Therefore, it is not a prime attribute. It is a non-primary attribute. It is not important when we are seeing from the table point of view. From table point of view, if I give you a PIN code, you cannot get me the details of others. Therefore, it is called as non-prime or non-primary attribute simply. If this non-primary attribute is working, if it is able to give us some other value, then such dependency is called transitive dependency. So try to remember these two words. They are very, very important. Also, the other meaning of primary and non-primary is we also have trivial, non-trivial. The English meaning of trivial is unimportant, non-trivial is important. These are basic concepts of normalization. And we have many types of normalization: 1, 2, 3, 4, BCNF, and of course again 5 normalized form, 6th normalized form as well. So we can discuss all of them. So we can discuss all of these normal forms now. Then first, imagine we have a table like this, which contains some ID and some values. What? Okay, before continuing with this normalization, why this is important, we have to see. It will take hardly 5 minutes, but that is also important concept. There are mainly 4 properties or 4 disadvantages of previous database. Initially, data used to be stored in a file format, which was very difficult. Then table format has evolved. It is RDBMS, Relational Database Model Management System. If let us take this example first. Imagine, let us take a university example where we have academic section is there. examination section. Let us limit ourselves to these two for now. When academic section will deal with the students academics and all those, there we have to give our name, roll number, our address. Of course, roll numbers college people will give us. We have to give phone number for communication purposes. Again, in the examination branch, we have to submit the details of us given by academic to examination. That means our data is present in two places for now. Again, what is the example? The more places we have to give our data, the more problematic it will be for us. Why? Simply, if in future the phone number of a person is changed, in how many places that person has to update? If the user is giving in 20, 30 places, in all the places, the person should remember wherever the details are given, and without fail they have to update, or else examination updates the person cannot receive, hostel updates they cannot receive. So it is risky. This concept having data in multiple places will, which is very difficult to maintain. The problem is called data redundancy. Never ever have the same data copied in two places. So the reason is pretty straightforward. Why redundancy should not be there? Again, for the very simple reason. Initially, imagine in the first year, I want a library card for maybe some books. Generally, in first semester, two semester, people will be more enthusiastic. So people are taking books from the library. I would have given some my phone number in library. But in the third year or final year, I am changing my phone number. Definitely in the academic section and examination section, I am changing the phone number. What will this lead us to? The name associated, this person is not updating their phone number in library, because in fourth year when I have changed my phone number, I am not interested to go to library anymore, so I don't want to update it there. Okay, no problem. If this is happening in all the sections, if the data is in 100 places, I only have work with the 10 places at the moment. I will update my details only in 10 places. What about other 90 places? The data is different. There is no consistency in the data. This is called inconsistency of the data. So never have multiple copies of the same data, because redundancy in the data will lead to inconsistency of the data. These two are normal English words. If you are good with their meanings, if you understood them, we will be using them again and again. You can understand other concepts as well. Now, again, coming back to this normalization, we cannot allow redundancy of the data. If there are multiple phone numbers in a single column, whether the user is changing first phone number or second phone number, I have to go to this block and update. That means the more details we have in one place, the more chances to get the errors. Because whatever data I want to update, I have to go there only. This is not allowed. What is this called? It as multi-valued attributes. In a single attribute phone number, column name is attribute, we have multi-values. This is not acceptable, or simply it is also called as composite attributes. So how to do that? Normalization function. I told you, right, while discussing this join, let us not remember for now what is join, why we are using joins and all. If the tables are separated, in the future for temporary purposes, we might want to join them again. So we have seen how to join them. Now we are seeing how to separate them. We are decomposing each table. Therefore, the process is called decomposition. That means separating simply. Now I am separating this table into two little tables. Of course, right now, we are just separating only one value is allowed. So I'm taking roll number 15. The name is J. One phone number I'm taking, state. I am separating roll number 15, J, second phone number. This is called first normalized form. Okay. Then when it comes to second normalized form, again, what is the disadvantage in this table is if ID 15, that person is changing their location, for example. That means if the person is changing from Telangana to Tamil Nadu, in how many places I have to update this again? Multiple places, more than one place if we have, it is problematic. The concept is very simple. The more places the data is, the more changes we have to make, the more chances of mistakes. If the data is in one place, if I am changing, I have to change only in one place. Even if I am doing a mistake, only one mistake is present. But if our data is stored in 100 places, then there is a chance of the persons doing 100 mistakes as well. It's a probability, statistics again, right? Therefore, we will try to reduce that. Since in the same table, if we have, it is problematic. Therefore, first value in columns, we did not allow duplicate values, first normal form. Second normal form, even in rows, we will not allow duplicate values. That is second normal form. So in 2NF, we are trying to remove the redundancy in the same table. After the same table, I have copied it here again. Once I am converting it to 2NF, now we are doing decomposition. That means the tables are decomposed. How am I decomposing? I'm just having the list of all the IDs, their names, their states. Then separately, if we are decomposing the tables like this, and there is no direct code available for normalization, we have to do that manually. Like for joining, we have join keyword. With outer join, inner join, using some keyword, we could easily join them. But when it comes to this normalized forms, we don't have direct keywords or functions available. We have to tweak it a little. Okay. So now this is called lookup tables. This word we will be using again and again. All the compiler designs, they will use this term lookup tables. Why is it good now? This table is in one first normal form. This table is in second normal form. Now, if I want to update the phone number, I have to do it only in one place. If I have to update the state or address of a person, again, if I do it in one place, it is sufficient. In this, if I have to update phone number, okay. If I have to update the state of a 15, one and two places I have to change. Now, the address, only there is no duplicate values. The phone numbers, there are no duplicate values. This is second normal form. Then we have third, as I told, till 7 normal forms they are existing. Of course, even 7 and 8 we have. But the thing is, we will not be using all of them. because they are under standardizing processes. It is not yet officially standardized by any international organization. The third normal form, if there is any transitive dependency, we have discussed in the beginning. What is transitive dependency? Zip code or pin code. These are not correct zip codes. There are some example zip codes. City is dependent on this one. State is also dependent on this one. There are two problems here. First problem, this table, if anybody is joining in this organization or student from the same zip code, I have to type again from the beginning everything. Suppose I am making an error. Why are we learning all this? Of course for infyTQ, but why these concepts have been developed to reduce the number of errors. While copying, if I made a mistake, now what is happening? This leads to inconsistency as well. Why? Observe the zip code of Hyderabad. One, it's 5 lakh. Second, it is 5 lakh one, which is correct. If the data is having multiple copies, then there is chance for multiple errors. We don't know. We cannot tell for sure what is the zip code of that particular area now. That means there is problematic. Then we should not use that in the same table. We should somehow separate it. So that is the first problem here. Second problem is, if there are multiple people from the same area, here I am creating 3 into some X blocks of memory. So imagine if it requires 1 MB of memory, I will require 3 megabytes of memory to store each of this value. Since there are around 7 to 8 values present here, 24 MB of data we are using because 8 columns. But Hyderabad is repeated. Again, Vizag is repeated. Hyderabad is repeated 3 times. Shimla is repeated. That means there are only 3 places. So in 9 MB of memory, we can simply use this. Therefore, this is third normalized form. If you want to convert it, simply observe which is important one among these 3. If I give you city, you cannot tell state. If I give you state, you cannot give city. But if I give you zip code, you can easily give me city and state. Okay. So based on that zip value, we have to separate the tables. We will be given some IDs. The IDs and names we are not changing actually. Only zip codes we are storing here. Like a lookup table, we are creating a separate table with these values. Now this is called foreign key. That means in this table, zip is a primary key, but in this zip is nothing actually. So here zip is called foreign key. It is enabling us a link to other table. From this table, the link to other table is created, and in the other table, this is the important value. This kind of keys are called foreign keys. That if you want, you have to write foreign key while creating. So this is called third normal form. If we are achieving that, then next we will have voice code. or BCNF. Persons called boy squad has given this normal form. It is that from here onwards, everything is very similar. Small changes have to be made. In boy squad form, we will not take even if there is any repetition in non-primary key attribute. We have two types of keys called candidate key and super key. Candidate keys are a combination of keys which will give us an insight on the table. If I give you a name, you cannot tell me the details of that person. But if I give you name and address, or name and phone number, or name and some other detail, the combination of these two can be used to find the details of that person. Such are called candidate keys. So for example, if I give you course ID and course type, we can get the details. For example, if I give you ID and courses, you can again get me the details of a particular person. They are called candidate keys. The union of all these is called super keys. That means from super keys, you can pick any combination, you will get the details, unique details of the table. That is the idea here. Now, how this boy squad normal form would work? Very simply, we are dividing it into further tables where based on ID and country, ID and courses, then about that courses, a separate table. There is no duplicate values now. That means a student is doing what courses, look up in one table. If in the second semester student is going to some other course, only if we change this particular table, that would be sufficient. Then this is the address of the student. If student is changing the address, update only this table, that would be sufficient. Based on the work you have, you can select the table and the process continues. Now, based on the courses the person is taking, if you want to find out the details, more details about that course, whether the code is mandatory, this example is given from the perspective that generally for any universities, you will have this optional courses, mandatory courses. You can take this and do up. So this is table. We are dividing it into three types. This is BCNF. From infyTQ perspective, more questions you can expect on join statements and this normalized forms. They will show you two tables and ask you, they will give you options. They might, and we should be in a position to select which is a first normalized form, which is a second normalized form, and such things. Then fourth normalized form. From here, it is almost similar, but real time problems we can come across from fourth normal form. Here, if I want to find the details of students based on their ID, the courses they are taking in Julia is one new programming language which is becoming quite a popular in the last 5 years. It's an open source project created by MIT students, which will follow both functional programming and modular programming. Like that means C is available in that, which will compile the code. Python is available in that, which will interpret the code. We can use flavor braces. We need not use flavor braces. Both are acceptable. So the popularity of this language is increasing. The reason we are telling this is when you go for interviews, you should be having idea on the upcoming trends as well. All right. Now, what is the relation between courses and activity of a person? If your university or college is keeping a rule, you definitely have to take one course at least outside of your academics. You definitely have to participate in one sport at least. Now the student one is taking 3 courses and is playing 2 sports, only 2. Since we cannot keep it null, we are just entering the name of the other sport as well. We are repeating it. Now fourth normalization means these two are independent attributes. These two you should not keep in one table. If the person is changing the sport he or she is playing, it will be very difficult to change. There is a chance for duplication. So ID and courses in one place, ID and sport in one place. Independent attributes are not allowed in a single table. That you have to keep in mind for fourth normal form. And the final normal form is fifth normal form. This courses and faculty is one combination. That means which faculty will teach which course, and faculty and semester is another combination. These are not fixed combination. That means in first we generally have this. When in intermediate we have 2 subjects called math A, math B. The faculty who teaches math A for the first year will teach math B for the second years. The combination will work like that generally. The faculty which teaches math A for the second year will teach math B for the first year. That means there is no fixed. If I am teaching math A for first year, there is no rule that I have to teach the same subject for second year as well. As I told, the more algorithms will start from this fifth normal form. Of course, this is the last form that is important for you to know. So since there is no relation between any of these two whatsoever, it is always safe to maintain them in safe separate tables. What if B is started to teach to another subject, or if the B person is going to another semester? We cannot tell that for sure. That's why we are decomposing it into completely separate tables. Which faculty is teaching which subject, a separate table. Which semester persons, students will have which courses, separate table. Which faculty is going to which semester, separate table. Now in the future, if the faculty is changing the years, that means the person teaching first year now is starting to teach for second year. Only this table, if we change, that's sufficient. If it is in same table, we have to observe why. If B starts teaching Java for second year, we have to check B data structures. This is not the combination we want. B Java, this is not the combination we want. This is the combination. We have to go like that, which is very difficult. As I told you, if there are hundreds of records, it will still become difficult. Therefore, we should not do such things. We have to maintain the records separately. Now, this is decomposition, and of course, this is fifth normal form. To complete this concept, all this normalization, whatever we have done, we are separating them into tables. It is called a decomposition. Decomposition is of 2 forms, lossless and lossy. What do we mean by lossless and lossy? When A, B, C, D, E are in one table, B is dependent on A. Okay, I think I can directly take this zip code table. Now, city and state, they are dependent on zip. That means one relation is, if I give you zip code, you can give me definitely city comma state, one relation. Again ID, if I give you ID, you can still give me city and state. Now these are two relations available in our table. When I am decomposing this table, what is happening? If I give you zip code, can you give me city and state? In this table is separate, this lookup table is separate. If I give you zip code, from this table's point of view, you cannot give me state value and city value of particular zip code. Therefore, if the original relation before decomposing and after decomposing, if there are any changes, it is called as lossy decomposition. If the relation is same, when the table is together, whatever relations are there, when we separated the tables also, if same relations are present, then it is called lossless decomposition. They will give you two separate tables and simply ask you to pick up the option lossless decomposition, lossy decomposition, something nothing, or no decomposition. They'll give you such outputs when you go for exams. This is all about your normalization. Then coming finally to MongoDB, it is a no SQL database. That means when there is no structure in the data absolutely, then we will use these NoSQL databases. MongoDB is one of the upcoming and familiar databases. There are hundreds of databases out there. To give you an example of NoSQL, I have selected MongoDB. That's all. Now, since this MongoDB syntax is same as Python, if you know Python, any question they are showing you in MongoDB, you can understand what is the output. How it will work? Simply, if they are showing you db1.create collections, for example, what would this do in Python? This db1 is some object, only then it will work. Object name dot some method name. Create collection is some inbuilt method. But the names in Python are so good. By looking at the name, you can tell what something is doing actually. So create collection, you can see and you can decide that this method is used to create a collection. What is collection? Don't worry, I'll tell you now. The name of the collection is, I am taking collection one. Coming back to collections, as I have already told you, okay, this is not the collections. Don't concentrate on that. In DBMS or RDBMS, we have tables or we have records, that is rows and columns. But in MongoDB, since it is unordered, that means one student will give, for example, name, phone number, address. If other student is not at all having the phone number, but he is or she is having name, address, and some other details, some reference. In RDBMS, fixed values we can take. I want name of all students. I want roll number of all students. If you are giving me extra details, I am sorry, I can't store them. That means from terms of RDBMS or DBMS, extra values cannot be stored. When it comes to no SQLs, anything, extra values can be stored. Therefore, here we will not have tables or records. Here we will have a collection of data. And to avoid confusion, these collections and that are different completely. All right. So if this is a database already existing, we are telling the machine to use it. This is the basic syntax in MongoDB. Or if you want to create the database, automatically the same line will create a database. In MySQL, whatever we did, create database followed by database name. These are keywords. Followed by database name and semicolon. The same thing in Python. Since MongoDB is built on Python, simply use database. That's all. Then there is something called name aliasing, as I told you. Sometimes when we are if the name is very long and it is difficult for us to call the big name each time, we will use this name aliasing. So instead of calling database1, I am giving a shortcut, a nickname to that, DB1. The syntax in MongoDB is like this: switch to DB database1. That means switch the name from database1 to DB1. These names are anything, you can take anything. In place of DB1, you can substitute anything. In place of database1, you can substitute anything. Then create collection is an inbuilt function or method. So DB1 dot create collection, it is creating a collection. Like in RDBMS, what we will have is exactly tables, only tables. But here we will have these sheets, like one student details. If I want, I can store it in entire sheet. So if the student is giving small data, if the student is giving very large data, I can still accommodate everything inside this same file. Then like show collections will show all the collections available. Also, you can give some parameters, like what are the column names you want to create, what are the values you want, whether you want indexing, what is the size of data you want to store, and anything. MongoDB is a separate vast subject again. DBMS, RDBMS, SQL together combined, how much data we have only on MongoDB, we will have that much data. So to show you the basic syntax, how it will work, same as Python, it is working. Now by reading the names itself, you can understand what is happening. That is our aim, to show you this. This is all about the database concepts that you have to know for attempting mainly this infyTQ exam. I hope everybody have understood the session, understood all the concepts that we have discussed in this session. Let us know if you have any queries or anything in the comment section or chat section. Okay, as per the request of one student, in third normal form, transitive property, transitive dependency is not allowed. If there is any dependency, it should be on prime attribute only. Okay, on other values, we cannot have this dependency. So we have to separate that into different tables. Now BCNF is exactly 3NF with a small change. The change being in this BCNF boys code, we cannot have the details which are mixed up. For example, let us take this table. These are the list of students. For simplicity, I am taking only 2 students. This is their countries. Now these are the courses those students are taking. University made 5 mandatory courses, 10 optional courses. So you have to do at least 1 mandatory course, 1 optional course. You have to pick up. So student number 1 has picked Python as their mandatory course, and student number 2 has picked Julia, as I told you, upcoming programming language, as their mandatory course. And student number 1 has picked machine learning, student number 2 has picked artificial intelligence as their mandatory course, as their optional courses. This mandatory and optional, there is a chance that it will be changed in the future. That means based on many reasons, like let us take one live example, this corona. Because of this pandemic, the way exams are evaluated, the pass percentage, many of these things have been affected. Most of the universities exams, I'm not talking about all universities in general, but most of the university exams, they have reduced the pass percentage marks. They have changed the question paper pattern, where at least if the student is preparing for 2 units, he or she should get 80 or 90% marks also. Previously, you have to read all 4 units and answer at least one question from each unit. They have changed this because of this pandemic. When we are learning subject, how they will have concept is under any circumstance, whatever it is, we should not face the problem. So in this table, if this university decides to change the course in the future, it is problematic. The mandatory and optional course type, if they are changing, it will be very problem. So it is not allowed. That is what these boys got. They have put it forward. So what we have to do, as I told you, candidate keys. We have discussed about candidate keys and super keys. This combination should not be, these combination should not be taken. Yes, so based on the request of one or couple of students, I am repeating that again, BCNF and 5CNF. How are we separating this BCNF is, again, without problematic. Separate the ID first. If the user is changing the address, this table is having a problem. It is not in first normal, it is not in second normal form. You have to change that separately. Then the most important thing is, what is the, this course type and course ID are for universities purposes, not for student purposes or parents purposes. So in the Outlook, it is useless to display them. In the first look, when you see, we would like to know what courses a particular student is taking, not whether it is mandatory or not, whether it is what course ID it is. All these course IDs are for university or college purposes. Therefore, this unnecessary data, or sometimes called as non-prime attributes of our candidate keys, have to be taken in separate table. That means this is the important table here. A student whose ID is 1 taking Python and ML, or student number 2 is taking Julia and artificial intelligence. Now, what course is mandatory, what course is not mandatory, that all is for the purpose of university. Why trouble it by including it in the general output? So we have to take it in the separate table. But for looking it is good. Also for changing in future, it will be good again. This is BCNF. Then in 4CNF, if two values are not dependent on each other, if these two are not dependent, they are independent, they should not be taken in a single table. That is for CNF. 4NF. Coming to 5NF, again it is similar to BCNF, but the difference is always a faculty will not teach the same subject. Always a faculty will not go to the same semester. Time to time, there is a very high chance that these details will be changed. Then this table will become useless. We can't even create a copy of this table and change the details there. It is also useless. So to avoid this, 5NF we have to use. What does 5NF state is? If there is any change in the combination, always lecturer B will teach data structures to semester 1 every year. If that is the case, this table is good, no problem. But we can't say that. Of course, in big universities, in medium colleges or universities, this is okay. But for very big universities or in general scenario, as I have already given you the example, if right now I am taking DBMS session, if always I am taking only DBMS session for only third year BTech students, then I can include my details here. Some faculty E, always teaching DBMS, always for 5th or 6th semester students. But that is not the case. For next company specific thing, I will be teaching some other subject to some other students entirely. Your seniors, most probably 8th semester students will have their C or Java or data structures for some other company specific or general classes. That means any faculty can teach a different subject for different semester. So to simply put, this combination is not fixed always. Till now, 1, 2, 3, 4 NFs and BCNF, we have seen only multiple values or duplicate values, row wise, column wise. But now we are seeing as a tuple. What is a tuple? CS taught by A to first. If this is not fixed, please do not keep in the table. That is what 5NF is all about. That's why, how are we dividing this table into? First, which faculty goes to which semester in a separate table. Why we are separating? If in the next semester, A is going for, suppose, semester number 2, simply if I change here, that's sufficient. Excuse me. Then, which semester has which subjects? You know, universities generally will change this from time to time. Suppose in this 2021 batch who are studying in first semester, who are just joining, if they have C language and data structures, for example, then after 2 years, they will change the subject, right? What you are studying now is not the same subject what your senior studied. Of course, again, in our universities, it's not a rule, but generally, that is how education should work in foreign universities or even here, very top universities. If the university is good, every 2 or 3 years, the subjects or syllabus will be changed. Now, simply, if I change in this table, it will be sufficient. If it is combined, if our first semester subject is changed, imagine there is no data structures, they are including Julia. But B person cannot teach this Julia, then I have to make many changes, which is very difficult. I hope now everybody understood the perfect concept. So only semester and subject separately, then subject and faculty. If faculty is changing subject, change in one place. If here that is happening, if A stops teaching CS and starts teaching data structures or data science, but that is not there for semester 1. See how many changes I am making in one table. The more changes you have to make, the more chances are there for errors. Therefore, it is not allowed. And this is your 5 normalized 5NF and BCNF. So I hope everybody have understood and learned something from this session. All right. One thing everybody has to remember, for this infyTQ mainly, try to sit in a proper position for before your webcams. Try to avoid any shadowing on your side. Also try to avoid looking here and there during the while writing the exam, because since it is not observed by human beings, most of the time they will be using artificial intelligence to invigilate this. There is a chance that if you are looking in some other directions other than webcam or screen, they might easily think you are cheating in the exam, and there is a very high level risk that you will be completely disqualified from the exam. So try to not look in the opposite directions. Try to look at webcam or screen always. And also try to avoid any shadows, because again, because of the shadows, they might think some other person is standing there along with you, maybe helping with your answers. There is a risk of that. So try to avoid these things. You can do good in exams. Then one more question. While decomposition, each table will have a loss of information, right, sir? Then how non-lossy decomposition exists? Uh, Again, actually the information is not lost anywhere, just the relation is lost. But that is not the case always. How I can show you? Yes, let us take this only as example. This table, if we take, what are the two relations that are available here? If I give you ID, you can give me course. If I give you ID, you can give me activity. Even after separating, if I am giving you ID, you can still give me course. Again, even after separating, you can still give me activity. That means the relation what we have initially is same here also. There is no change in the relation. Course is dependent on ID. Activity is also dependent on ID. That is not changing. So there are cases, there will be cases where the relation is not changed. That's when the non-lossy decomposition. It's actually called non-lossy. It is called lossless. Therefore, lossless decomposition also exists. We should have a sharp eye and guess that which is dependent on which thing. That's all. Example for lossy to sir. I think we have already seen the example for lossy with this zip and all. If because of separation, yes, let us take this only. If I am giving you a combination of name, city, state, it is all in the combinations that we are able to select everything. So if I give you ID, you can give me name, city, state. This combination, we can find it. Same way, if I give you a combination of these three things, name of a person, state of a person, city of a person, then you can give me ID of a person as well. But after the normalization, after decomposition, now I cannot take name and state city in one go. City and state is in separate table. Name and zip is in name and ID is in separate table. Therefore, this relation is not present in the tables now. This is called lossy. Our relationship, the relations of table when it is together is not available when the relation is separated. Therefore, it is called as a lossy. This is lossy and lossless. Again, I am reminding to the people present in the session, do not try to create everything on your own. The topics which we discussed, you will have in your academics in different semesters for at least 3 semesters. DBMS 1 semester, normalization, general DBMS, redundancy, inconsistency, everything 1 semester. RDBMS, tables, joins, explanation, concept, 1 semester. Then SQL, select keyword, create keyword, the syntax of everything, separate subject, separate semester. So 3 semester subjects we try to discuss in a short time. So definitely in one go, it is difficult for anyone to understand without proper basics. That's why you have to know what you are trying to do here, why you are here. You are not trying to learn the entire subjects. You can't do that in a one day before. But if they are displaying the questions and you are able to justify those questions and guess the output, that is good for now, the present situation. That is where you should hope you have to be. So these concepts will help you do that definitely. That's why you are unable to do it in one go. Yes, this is the reason for that. I hope now you can do that. All right, everyone. All the best to everybody for your infyTQ or in general. Good for listening to the session and hope you have learned new concepts. Yes, you are welcome. Then that's all for this session. Hope we will meet some other time again. Good evening, all.
Hi guys, I think you have been enjoying the session a lot. I think the session might be like useful for you guys. So yeah, we came to another session and we are trying to close the session off. And thank you for your uh, being and supporting us with the last 2.5 hours. And thank you guys. All the best for your exam, which you're going to write tomorrow in infyTQ. And all the best for you guys.